On December 25, 2021, at 12:20 UTC, all progressive humanity gasped in anticipation. And for the next few tens of minutes, they were holding their breath, afraid to breathe in and out as the launch of the James Webb Telescope took place. It was a difficult, long-term construction on which a whole new generation managed to grow up. But fortunately, it turned out to be a long-term, successful construction. The launch was flawless, as was the telescope's journey to its final destination, the Lagrange point L2. The telescope is named after NASA's second director, James Webb, who led the agency from 1961 to 1968. James Webb boasts not only its gigantic size with the height of a 3-story building and the length of a tennis court, but also its capacity. NASA claims that in visibility, it bypasses Hubble by 100 times. James Webb can see the first galaxies formed after the Big Bang over 13.5 billion years ago. And now, after all the settings, calibrations, and tests, it began to deliver the first scientific results. For the debut research, an international group of scientists chose 5 objects: exoplanet WASP-96b, planetary nebula NGC 3132, star-forming region NGC 3324, group of galaxies Stephan's Quintet, distant cluster of galaxies SMACS 0723. Why these particular objects? Well, first of all, they are beautiful. No jokes. The purpose of the first observations was not only to satisfy scientists, but also to make a showcase for a visual demonstration of the capabilities of the instrument, to take everyone's breath away, and even melt your heart. Spoiler, they succeeded, even with a decent margin. The scientific value of the first results exceeded all expectations. So let's go. Well, here are more details. James Webb Telescope, first results. Exoplanet exploration is one of the stated goals on the Webb agenda. To date, about 5,000 exoplanets have already been discovered, and scientists are no longer interested in discovering new ones. They want to learn more and deepen the understanding of the known ones. And the new telescope immediately impressed with a bright result. Meet WASP-96b. Well, unfortunately, no pictures, but there is something more interesting and important: the spectral data of its atmosphere. The planet is 1,100 light-years from Earth and is a typical hot Jupiter. It is the term used for the gas giants, which are very close to their luminary. The temperature on the conditional surface of WASP-96b is about 1,000 degrees Celsius. What Webb has found on the planet is very puzzling for the experts. Telescope data reliably showed the presence of water vapor, signs of haze in the atmosphere, and even the presence of clouds. The new data immediately transformed the previous theory about hot Jupiters, as previously it was believed that there could not be clouds in the usual sense on such planets. Although the planet was one of Webb's main targets, the telescope failed to make a direct picture. Nevertheless, we can still enjoy a visual image of one of the most mysterious exoplanets. On September 1st, NASA released a snapshot of another space object, the exoplanet HIP 65426b. It was a remarkable result of the telescope, which clearly demonstrated its capabilities. HIP 65426b is a gas giant located 385 light-years from Earth. The planet is very young. It is only 15 to 20 million years old. Astronomers discovered it back in 2017, but back then, technology was not enough for any intelligible information. Using data from James Webb, experts were able to find out that the radius of the planet is almost 1.5 times the radius of Jupiter, and its mass exceeds the mass of Jupiter by more than 7 times. The exoplanet is a typical so-called hot Jupiter without a solid surface, with a temperature of the upper layers of about 1500 degrees Celsius. Of course, the exoplanet is nothing like Earth. That is why no one was going to look for signs of life on it. The task was to obtain an image with minimal time and effort, and Webb handled it perfectly. The image of the planet was made using various instruments of the telescope, in particular the NIRCam near-infrared camera and the MIRI mid-infrared instrument. On the top image, we see not the planet itself, but the star around which it revolves. The exoplanet you can see in the 4 frames below. In order to distinguish the planet in the bright light of a star, scientists use a special device, a coronagraph. The value of this photo can hardly be overestimated if you understand the specifics of how it was taken. Before the Webb telescope, the process took a very long time and laborious efforts consisting of many stages. Webb was able to capture a photo of a distant planet in almost 1 instant. It opened up new horizons in the study of exoplanets. As we continue, and here we finally see the photo, even as many as 2 made by different Webb tools. It is one of the most beautiful cosmic phenomena, a planetary nebula. Here it is, one of the most famous and well-recognized, the Southern Ring. Such amazing cosmic structures arise in the latter stages of the life of sun-like stars. A star burning thermonuclear fuel throws off its upper layers, which scatter in outer space like fireworks. Webb's tools allow to look into the very center of the nebula and to see in detail what is there. And there are as many as 2 stars revolving around each other. Moreover, one gradually loses mass due to interaction with the other. One star literally pulls on itself the matter of another. It was a dimmer star that gave birth to the nebula, and now a brighter companion star is eating it up. The process will last for many years, and we will be able to watch it live. One more, and even an epic photo. A cluster of cosmic gas, which looks like very dense clouds. It is part of the star-forming nebula NGC 3324. In fact, the concentration of matter in these clouds equals only a few atoms per cubic centimeter. However, it is enough for this area not only to look impressive, but also to become a real cosmic manger. It is in such nebula that an intensive process of formation of new stars takes place. And here too, the James Webb Telescope is finally giving us the opportunity to see individual stars in the nebula. Why finally? Because earlier, the capabilities of the Hubble telescope were not enough for such detail. The fact is that Hubble sees best in the optical range, and such relatively dense clouds are an impenetrable barrier to electromagnetic radiation in the visible spectrum. Webb, on the other hand, is a real magician in the infrared spectrum, and for it, these dense clouds are almost transparent. So now we have thousands of young massive stars discovered, and scientists are happily rubbing their hands in anticipation of new discoveries. Another spectacular photo published by NASA, 5 densely spaced galaxies. Indeed, there is a slight catch here. One of these galaxies is actually much closer to us, only 40 million light-years away. You can't confuse it with others. Webb is so powerful that we can even see the individual stars in it. The rest of the galaxies in Stephan's quintet are much more distant, about 300 million light-years away. Those 4 are really located very close to each other. They are interesting precisely for their proximity to each other. At such short distances, a direct gravitational interaction produces interesting effects that we can observe in small details, in very minute details. After all, it is the most detailed photo of those published by NASA. The resolution is 150 megapixels, and the entire image is made up of thousands of individual frames. This photo delivered an interesting bonus. Scientists received a detailed elemental analysis of the gas around an active black hole in the center of one of the group's galaxies. Thus, by accident, the telescope made a tangible contribution to our knowledge of the evolution of black holes. Here, the scientists are more interested in the effects produced by the cluster. The cluster works like a giant gravitational lens and allows observation of even more distant objects. There is one which looks like a little inconspicuous red dot. In fact, this is an entire galaxy located 13.1 billion light-years from us. Now remember that the universe itself is only 13.8 billion years old. This is not just a very old galaxy, but indeed one of the first. We literally can see and measure the spectrum of the galaxy of the beginning era, when atoms were just beginning to form. It is also a very iconic image in itself. Back in 1995, scientists directed the legendary Hubble to this part of the sky, and it took a really impressive photo. It turned out that in a rather dark and tiny place of the celestial sphere, in fact, you can see almost an infinite number of galaxies. And so, in 2022, Webb already examined the same section of the sky. See the difference? It's like turning on a light in a dark room. It took Webb only 12 hours to do it. Yes, exactly, only, while the grandfather Hubble had to work for the exposition for 10 whole days. This short NASA photo report is far from being a complete account of the telescope's achievements. James Webb turned out to be unbelievingly lucky and managed, according to preliminary conclusions, to record a supernova explosion. When scientists compared Hubble footage taken in 2011 with Webb's observations of the same area, they found something unexpected. An unremarkable dot could turn out to be a very remarkable event. The data still needs to be verified, but there is a high probability that this is the supernova explosion. It is a fairly rare occurrence and often very fleeting, so you need to be very lucky to catch it. James Webb seems to be able to surprise. Well, if the all-impressive above-mentioned list is composed from the beginning work of the precious in every sense telescope, then we can just imagine what amazing discoveries it will bring in the future. And we will definitely keep you updated.